Hi guys, so here's our notes for 5.3 non-parallel lines and transversals. In 5.4 we're going to be looking at the same vocabulary words that we learned today but in parallel lines, so relationships between them. Today we're just getting the vocabulary down. So first bit of vocabulary, vertically opposite angles. And they are angles created by intersecting lines that share only a vertex. So if I take a look at this angle here, so this angle here, if I take a look at this one, they share a vertex, so a point. They share their vertex, but they also share this arm. So this angle here is not going to be vertically opposite to this. Neither will this one, because once again, they share a vertex, but they also share a ray. They share an arm. Okay, so our last one is right here. So vertically opposite, right across from each other, opposite to each other. So vertically opposite, it's a V. Its vertically opposite pair will be right across. So taking a look at the other angle here, so this angle, its vertically opposite partner will be right across from it, right opposite to it, vertically. So here points right to its pair. Our next vocabulary term is transversal. So a transversal is a line that intersects two or more lines. So in our above example, we only have two lines, so we do not have a transversal there. But here we have one line, two lines, three lines. This one that goes through both this line and this line is a transversal. Line 2 is not a transversal because it only goes through one line here. If it extends, if we extended it, it could be a transversal there, because it would go through this line and that line, but in our drawing, it is not a transversal with just the lines that I have drawn here. So transversal cuts off two or more lines. Next vocabulary term, we have corresponding angles. So corresponding angles are angles that occupy the same relative position in two different intersections. Okay, let's think about that. Whenever I have two lines coming together, I have an intersection. So here I have an intersection up above. Here are two intersections there. Here's one intersection here. So when we're talking in this unit about different intersections, it's okay. Here's one intersection. Here's another intersection. If I'm looking at this angle here, then it's in the, for this intersection, the way we're looking at it, it's kind of in the top right. So it's in the top right corner. So going down to this intersection, I'm looking for what's in the top right. Okay, so this angle is also in the top right. So it is corresponding to this angle here. Or I could look, for example, to this one. So this angle is in the top left. In this intersection, here's the top left. So those two will be corresponding. You could do the same for this angle here. So this is bottom left. Here's bottom left. And for this angle, here's bottom right. There's bottom right. So corresponding. All my purples are corresponding, these green ones are corresponding, this red is corresponding to each other, and this blue is corresponding to each other. So here we have four pairs of corresponding angles when I have two intersections. Okay, next. So alternate interior angles are angles on opposite sides of the transversal inside of the two lines. So if I break this up, so interior angles are in between my two lines. So here's my one line, here's my other line. My interior angles are going to be all of these. Now, alternate interior angles, well, alternate you can think of as like kind of like opposite. Okay, so alternate interior angles, well, here is my interior, one of my interior angles. So alternate interior is going to be kind of like opposite. So on this other side of my transversal, so on the opposite sides of the transversal and inside the two lines. Okay, so why it is not this one is that this is not on the opposite side of my transversal. Okay, so opposite side of my transversal. So kind of almost kitty corner. If you look at that, it makes a Z. Okay, so one here, one here. There's only one other pair of alternate interior angles, and that would be looking here. So here's one angle, sorry, its alternate interior partner would be here. So opposite side of the transversal on the other side, but still an interior angle. So those and those. Next bit of vocab. So alternate exterior angles. Going to be very similar to alternate interior, except we are looking at the exterior angles now. But same thing, we're looking for angles on opposite sides of the transversal. So those are my exterior angles, so on the outside of my lines. So if I'm looking at this one, alternate exterior, well, it can't be in here, that's vertically opposite. This is an interior angle. This is not on the opposite side of my transversal. Here we go. So alternate exterior, like this. There's only one other pair of alternate exterior angles, and that's this one and this one. So alternate exterior. Next bit of vocab. We have same side interior angles. So with same side interior angles, we have angles on the same side, so not alternate now, we're looking at the same side of the transversal, and interior angles. So here are my 4 interior angles, this one, this one, this one, this one. And same side interior is going to be, okay, here we have one, and here is another. So they're on the same side of the transversal. So same side interior angles. So same side of the transversal, and they're inside the 2 lines. So same side interior for this one will be here. Last one, same side exterior angles. So just like we had same side interior and alternate interior, we have same side exterior angles, as well as same side interior angles. So same side exterior, looking at my exterior angles, so on the outside of my 2 lines, so these 4, 1, 2, 3, 4. And if this is 1, then same side exterior is going to be, okay, same side of the transversal, and then an outside angle. So here we have same side exterior angles, and this one will be same side exterior with this one. Okay, so 2 different pairs, 2, 2, 2. Example number 1, identify which line is the transversal, then identify all angles of each type. So taking a look here, we have line 1, line 2, and line 3. Now, a transversal is one line that cuts 2 lines. Okay, so line 1 only cuts 1 line, line 2 only cuts 1 line, line 3 goes through 2 lines. So line 3 is my transversal. Now, identifying angles, all angles of each type. So looking at my corresponding angles. So let's just start at 1. So going from 1, what is corresponding to 1? So looking at the definition of what corresponding angles are, it's going to be, well, this is in the top left. Number 5 is in the top left of the bottom intersection. So number 1 and 5 are corresponding. And how I write that this is an angle, so angle 1 and angle 5 are corresponding. Looking next, I have, just going in order, let's go angle 2. What's corresponding to angle 2? Well, angle 2 is in top right. Angle 6 is in top right. So angle 2 and angle 6. Then we have angle 4 here in the bottom right, angle 8 in the bottom right. So angle 4 and angle 8, as well as angle 3 and angle 7, both occupying the bottom left spots. Now, vertically opposite angles. Remember, vertically opposite is your V points to your vertically opposite partner. So vertically opposite to number 1 will be right across from it, number 4. So angle 1 and angle 4 are vertically opposite. Same thing with 2 and 3. So angle 2 and angle 3. as well as angle 5 and angle 8, as well as 6 and 7. Right, alternate exterior angles. So alternate means the opposite side of the transversal, and we are looking at our exterior angles. So my exterior angles are here and here. So alternate exterior is going to be if I'm looking at 1 on the opposite side of the transversal, and external angle is 8. So 1 and 8 are alternate exterior, which leaves 2 and 7. So opposite side of the transversal and exterior angle. So angle 2 and angle 7. Alternate interior angles is here's my interior angles, and then alternate, so on opposite sides of the transversal. So if I'm looking at 3, then alternate interior is going to be 6. And if I'm looking at 4, alternate interior, so opposite side of the transversal, and interior angle is going to be 5. You might be wondering why angle 3 and 4 are not alternate interior. They're on they are on opposite sides of the transversal, yes, but they are all on the same line. Okay, so they would not be considered alternate interior. We would call these, for example, supplementary because they cut a 180 degree line, a straight angle into parts. So 3 and 4 would add up to 180 and be just supplementary because they are on that line, which we will get to more next lesson, not really this much, this lesson. So same side interior angles now. So same side interior angles, so still looking on the inside, and same side of the transversal. So 3 and 5 would be same side interior. And then I only have one other pair, and that's 4 and 6. So angle 4 and angle 6. And then same side exterior. We are just looking, oops, on the outside angles now. So outside and outside. So if I look at 1, oops, same side exterior, won't be alternate exterior. So 1 and 7 are on the same side of the transversal and exterior angles. So 1 and 7, as well as 2 and 8. So here we have all the angles of each type from these 2 lines with a transversal. Next example, example number 2. So in this diagram, we have to identify each of the following in our chart here and which lines and transversal we are using. So for example, if I'm looking at this line, and this transversal, then I have line 1 and line 2 as my lines, and my transversal is line 3. But there's a bunch of lines that cross together, so I could also look here. So this line and this line with this transversal, because this cuts both of these lines. I could look onto the other side, these ones, so this would be my transversal, 2 lines, or I could look down here, so transversal, and then line and a line. Okay, so it's really going to depend on what angles you are looking at. So you don't necessarily only have one transversal, you can have many transversals, because here we have lots of lines that cut each other. So first, I'm looking at an interior angle on the same side of the transversal as angle 6. So that sounds wordy. It's basically I'm looking for a same side interior angle as angle 6. So here's angle 6. So we have a couple different options we can use. Now, if I take a look at this transversal and these 2 lines, angle 6 is not an interior angle. So that is not going to work out for us. So line 1 mustn't be my transversal. So taking a look back down here at these lines. So here I have 1 line, 2 line, and a transversal that cuts both, and this makes my angle 6 an interior angle. So same side interior angle would be angle 2. So angle 2. And the 2 lines that I'm using are line 1 and line 2. And the line that I'm using as a transversal is line 3. And that's the only option for this one. So an angle corresponding to angle 2 now. So here we have angle 2. Now I'm looking for a corresponding angle. So let's take a look at the line we were just looking at. So our 2 lines and a transversal here. And let's see. So here's angle 2. Here's my transversal. And corresponding means, all right, angle 2 is in top left. So this intersection, top left, is going to be angle 1. So, and I'm going to ask you to write a little bit smaller because there's going to be a couple options here, or a few. So angle 1 is corresponding to angle 2, and that's when I'm using line 1 and line 2 as my lines. Line 1 and line 2, with line 3 is my transversal. Okay, let's take a look below now. So here's angle 2. If I take a look at these 2 lines, so line, line, transversal. So 2, top left, 4 is top left. So angle 4 is corresponding to 2. And that's when I look at line 3 and 4 as being my lines, with line 2 being my transversal. And there's actually even one more. If I just extend this line, it ends up cutting this line. So here I have 1 line, 2 line, and a transversal. Angle 2 is in the top left. Angle 3 is in the top left here. So angle 3 is also corresponding to 2, and that's when I look at my lines being line 3 and line 1. Should have left more room here. And line 2 is my transversal again. So 3 different options for a corresponding angle to angle 2. Next, an angle corresponding, again, to angle 4 now. So here is angle 4. And, well, we already know that angle 4 is corresponding to angle 2 from up here. So taking a look, angle 4, top left, angle 2, top left. When I'm using line 2 and line 3 and line 4 as my lines and line 2 as my transversal. So we know that angle 2 corresponds to it already. If I'm using line 3 and line 4, with line 2 as my transversal. And since 4 is corresponding to 2, it's also going to be corresponding to 3. Okay, so top right, top right. So taking a look at these lines. So also corresponding to angle 3. And that's when I'm using line 4 and line 1. With line 2 as my transversal. And let's see if there's one more. So taking a look, this is my transversal. Here I have 2 lines. So 4, top left, 7 is top left here in this intersection. So top left, top left. So angle 7 is also corresponding to angle 4, and that's when line 1 and line 2 are my lines. And line 4 is my transversal that cuts between them. And last one. So I'm looking for an alternate interior angle to angle 4. So here I have angle 4, and I want an alternate interior. So let's take a look at the lines we were just looking at. So here, and 4 is an interior angle. An alternate interior would be zigzagged across. So if I look at this Z here, here's one, here's my other one, and it is not a named angle, so that one does not count. Right, so no alternate interior angle there. So taking a look down here, 4 isn't even an interior angle, so those lines won't work. Here, here, here. So here we have 4 as an interior angle, and zip across, 4 will be alternate interior to 9. So angle 9 And that's when I'm using line 3 and line 4 as my lines, with line 2 as my transversal. Sorry, those are all really messy. So for our last example, you do need your protractor because we're going to measure all 8 of these angles, record their sizes, then identify pairs of equal angles, and we're going to figure out and be able to say why they are equal. So first off, we need to take our protractor and measure our angles. So this angle 1 is about, taking a look here, oops, 135, you extend your line there, 135 degrees. Oops. So 135 degrees. If your line is not going as far as you want it to, you can always extend it using your ruler. So if you extend your line using your ruler, you should be able to see exactly how long it is. So whenever on an assignment, if your lines are too short, just give it an extend. So here we'll be able to see a lot better that we are at 135 degrees. All right, okay, next one, measure, and 45 degrees. Now this is something that we would expect, because if I take a look here, here we have a line, just a straight line, not that I can draw one, but here we have a straight line, and angle 1 and angle 2 cut up that straight line. A straight line is 180 degrees, so angle 40, this 45 degree angle and 135 degrees, if you add them up, you get 180 degrees. So these two are supplementary. Not equal though. 45 and 135 are not equal. And in our question, we want to answer, well, what are my equal angles? So continuing on, measuring. So go measure, and I'm going to continue measuring. You measure on yours, give this video a pause, and let's see if we get the same answers. And taking a look. So 135 and 45 for angle 3 and 4. Then angle 5, I got 120 degrees, 60 degrees, 120 degrees, 60 degrees. Now taking a look, identifying pairs of equal angles. Well, I have two 135s here. So angle 1 and angle 3 are 135. And 45, 45, both angle 2 and 4 are 45. Now what do you notice about those two angles? Well, they are vertically opposite, and these two are vertically opposite. Okay, so let's see if that works down below. So taking a look at angle 6, it's 60 degrees, and oh yeah, its vertically opposite partner is 60 as well. And same thing with my 120. So here's angle 5 and angle 7. They are vertically opposite and both 120 degrees. So pairs of equal angles. So my pairs of equal angles are angles 1 and angle 3. We also have angle 2. Ugh. So angle 2 and angle 4. There is angle 5 and 7. And angle 6 and 8. And we see from all of them that they are vertically opposite. Okay, so we can gather from this that vertically opposite angles are equal. So vertically opposite angles are equal. And it does make sense, because if I remember that angle 1 and 2 are supplementary, 1 and 4 are also supplementary. And if angle 1 is 135 degrees, then its supplementary pair must be 45 degrees. So this 45 degrees is going to be both angles on either side of 135 that make up its lines. Okay, but you guys don't need to know that. So you can go on to your assignment 5.3, non-parallel lines and transversals.